Don't kill me. You can only make me stronger. I need you to hurry up now, cause I can't wait much longer. Move it out now.
I think it's a good place to stop. Hey guys, sorry I can't be there today. Just thought I'd start off the class here with a cool little video. Jimmy Fallon, Justin Timberlake, History of Rap. Apparently they've done this a couple of times. There's a 10-minute video here, and it's pretty awesome. That was just a very small snippet of it. So definitely go in and check that out sometime when you've got the chance. Yeah, definitely a cool watch, especially you hip-hop fans out there. Alright. Anyways, today we are doing section 9.3, domain and range. Okay, this is a very important section. This topic of domain and range we're going to look at, wow, really through, I want to say almost the rest of the year from this point on. Okay, so, but before we get to that, let's go ahead and take a look at the opener real quick. Okay. In the square SQUA, side SA equals 8. Okay, so that's this side on the left here. That's going to be 8. Find the area of the shaded region. Okay, now we'll notice we have two shaded regions, right? We have this one in the bottom left here, kind of looks like a slice of pizza, okay? And this one on the top right kind of looks like a curved triangle. I really don't know a better way to describe that, okay? Now, we know a couple of things. Okay, first of all, we know we have a square. All right, so all of these sides have to be 8. Okay. The other thing we know is we're talking area. Okay, and so area of a square is same as area of a rectangle, length times width. The only difference here is that the length and the width are both same, right? So for this square, the area is 8 times 8, which is just 64. Okay. So that's the area of the entire square. And I'll draw a little square symbol here. Right? The area of the entire square is 64. Okay? Now we got to put on our creative hats. Okay? If we take this little curvy triangle-ish piece, right? And let's say we were to move it to this empty white area right here. So here's my little triangle curvy piece, right? Just kind of turn around. Let me shade it. Oh, that's magnificently bad. And here's the little pizza slice piece. Okay. And what's actually going to happen is if I, smush both of those two together, they're actually going to fit perfectly with each other and make a little mini square. Okay, kind of like two Lego blocks going right on top of each other. Okay, they make a perfect square here. Okay, so how many of these squares, these smaller shaded squares, are in the larger square? Okay, well, let's see. Let's draw this in now. Okay, so if I were to shade this area right here, okay, there's my shaded region, right? I have a little tiny square right there, and it looks like I can split this square up into 4 smaller squares. So my shaded one, right, is one of 4 smaller squares that make up this larger one. Okay, so if I take the area of this entire square, divided by 4, I get 16, letter H. Okay? So interesting problem right there. I like that one. Okay, it requires a little bit of creativity. Alright. Alright, cool. So, quick opener there, a couple of geometry things going on. Alright. Now, before we get into domain and range, let's take a quick sec and review what we already know about functions. Okay? So, what makes something a function? Alright? And we've talked about this definition a few times. Let me see if I can get rid of that, give us a little more space. There we go. Whoops. What makes something into a function? For every input into a function has exactly one output. Exactly one. Okay? We associate the input of a function with x and the output with y. Excuse me. Okay? So, we remember from 9.1, 3 ways to represent a function. I'm actually going to start on the right here with equations. Okay? So let's let f of x, my function of x, equal 2x. And you'll remember this terrible drawing from that day, right? Inputs go in from the left, outputs come out from the right. Okay? We can also make tables, right? Kind of like what we did on last night's homework. We filled in some tables. You have x and f of x, which we're going to say is 2x. And let's do our usual -2, -1, 0, 1, and 2. So, let's take my inputs and put them into my function machine, right? If I take -2, plug it into my function machine, it's going to spit out 2 times -2, which is -4. If I throw in -1, it's going to spit out -2. I throw in 0, 2 times 0 is 0. Throw 1 in there, 2 times 1 is 2. Throw 2 in there, 2 times 2 is 4. Okay? Now, remember, right, all of these tables can also be read as points on my graph. For example, input of -2, output of -4 represents the point -2, -4. -1, -2 is also a point. 0, 0, 1, 2, and 2, 4 are all points on my graph here. So let's go ahead and graph this function. Here's my axes. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. X's are across, Y's go up and down. First point on my graph, -2 along my X's and -4 down my Y's. -1, -2, 0, 0, 1, 2, and 2, 4. Now, assuming my axes would have been well drawn, right, this should look like a straight line, okay? Y equals 2x. Okay? All right. So hopefully everyone's okay at this point. Everyone's caught up and good. Let's move on. Okay? A little bit of review there before we move on to new stuff. Okay? Part 3, domain and range using ordered pairs and tables. Okay? So you might remember these words, domain and range, from that metamorphosis video. Okay? Domain is a fancy way to say all of the x values of a function. Okay? Range, on the other hand, is a term used for all of the y values. And in general, you have a function when none of your x's repeat. Okay? And we'll talk about this a little later. Okay? But in order to have a function, none of your x's can repeat. Alright? Okay, so let's talk domain and range. Example 1. We have 3 points from a function here, right? I have 1, 5, 2, -3, -4, 3. Okay? My domain represents all of the x values from this function, right? What were my inputs? I input 1, and my output was 5. I input 2, output was -3. I input -4, output was 3. Okay? All these x values, these make up my domain. And you'll notice it's already in your notes, right? When we talk domain and range, we use these curly brackets, and I'll show you how to make those when we do range. But inside here, I'm just going to write all of my x values. 1, 2, and -4. Range, on the other hand, is going to be all of my outputs, right? Whatever remains here. I have, well, let's do the brackets first. Get a little bit of that. Oh, God. Oh, God, that's terrible. Oh, that was no good for anyone. Okay, let's try that again. There we go. That's a curly bracket. And so within this curly bracket, I'm going to throw in 5, -3, and +3. All of my y values make up my range. Okay? And last but not least, is this a function? Well, did any of my x's repeat? I have 3 points here, and I have 3 different x values. Oh, wow. I am not looking good here. None of my x's repeated, therefore, this is a function. Okay. Let's look at another one. Example 2. Again, domain is my x's. So, curly bracket to start. What are my x values? 2, 9, and 2. Okay. Now, in this case, I have the same x value twice. You do not have to write it twice. You only have to write it once. So in this case, just 2 and 9 make up my domain. Okay? Range again is going to be my y's. -3, -8, and 0. Now, is this a function? Okay, the answer here is no, right? And I'll explain why. Remember, the definition of a function we wrote on the first page was that for every one input, I have exactly one output, okay? So when I input 2 into this function, right, I got 2, -3, which was the first point here. But then again, I input 2 into my function, and then I got 0, okay? This is one input having 2 outputs, okay? This is not a function, okay? Not a function. Okay, this is a big no-no for us, all right? And we'll see more examples of this in the future sections, okay? All right, let's keep moving. Oh, hopefully everyone got example 2 down. If not, someone feel free to rewind this, okay? Example 3, right? Now I have a table, okay? But remember, a table is just another way to write ordered pairs, right? These are all points on the graph of my function, right? So, looking down my x column, right? Here's my x column, right? That makes up my domain. So, curly bracket, -6, -3, -2, 4, and 11. Range is my y values. Okay. I have 8, -2, 4, and now 8 repeats again 2 times. I'm not going to waste my time writing it every single time. Okay. So I only have 3 things in my range. Now, the fancy way to say is 3 elements. 8 is an element, -2 is an element, 4 is an element. That's not something you're going to need to know for the quiz or test. Just a heads up. So, looking back at my x column, right? Did any of these x's repeat here? Nope. Therefore, this is a function. Okay. All right. Let's go ahead and flip the page. Okay. So we just looked at domain and range using ordered pairs and tables, right? The last way we have to look at a function is graphs. Okay. So domain and range here is still x values and y values. Okay. And for a function, to tell whether a graph is a function or not, we're going to use something that we call the vertical line test. Okay. And what the vertical line test is, a function cannot cross through a vertical line more than once. Okay? A function cannot cross through a vertical line more than once. Okay? And we'll show an example of that in a little bit. All right? Excuse me. All right, let's talk domain. So, example 4 here, right? Here's a graph, right? This blue line, now I think it should be blue on the iPad as well, right? This blue line here is some function, okay? Here's my x-axis, all right? Now, I'm not going to write every single point that's in this domain. There would be an infinite number, right? Because, for example, I could say 0's in the domain, right? I could say 0.1. 0.01, 0.001, 0.0001, and so on, right? All of those values are in my domain, okay? So we have a different way of writing it, all right? You need to find 2 things, okay? So looking along my x-axis here, you are looking for 2 things. First of all, what is the smallest x value? Okay, so remember, x's get bigger as you go to the right. So if I want the smallest x value, I'm going to count them off to the left. -1, -2, -3, -4, -5, -6. Right? The x value of this point is -6. That's the smallest x value that I have. The next thing that I want is the largest x value. So now I'm going to count off to the right. 1, 2, 3, 4, 5, 6. And right at this point, the x value is 7. Okay? So I say that my domain, right, all of the x values in this graph are the numbers between -6 and 7. Now, the final piece to this is something we talked about way back when in chapter 1, okay? And that's brackets and parentheses, right? Brackets and parentheses. Hopefully, these look a little familiar, right? Remember, brackets went with closed circles. Parentheses used to go with open circles, okay? So, on my graph here, both of these are closed circles. So I go bracket -6, comma 7, bracket. Okay? This tells me that -6 and 7 are included in my domain. And I know they're included because I have closed circles here. Okay? Let's do the same thing for range. Okay? Remember, range is my y's. So my y-axis goes up and down. Okay? I'm going to do the same thing. What's the smallest y value on this graph? So here's my y-axis. And now I'm going to count down from 0. -1, -2. And right here, right at that point, right, the y value is -2. Okay? And as I look further below, right, there's no part of my graph that's down here. So the smallest y value I have is -2. And now the largest y value. So count up. 1, 2, 3. Right? At this point right here, the y value is 3. So again, I'm dealing with closed circles. My range is everything from -2 to 3. Okay? Alright. The last thing is this a function, yes or no? Okay? So I'm going to go ahead and erase all these additional lines I have here. See, it might be messing up the graph a little bit. Okay? This is where I'm going to use the vertical line test. Okay? If I draw a straight up and down vertical line anywhere along this graph, right, my graph is only going to intersect that line at one point, no matter where I draw that vertical line. So far I've drawn 4, right, and now here's 5, right. Every single time my black vertical lines have only intersected my graph at one point, okay. Therefore, the x's do not repeat, and this is a function. And the reasoning we say is that it passes the VLT, the vertical line test. Okay? The VLT. All right? Okay. Let's look at this again now. Example 5. Let's do the same thing. Okay? A little quicker this time. Domain, again, is my x values. Look along your x-axis, right? Where is the smallest x value located? And it looks like it's right along here, okay? So let's count down to that point. -1, -2, -3, -4, -5. Whoops, I lost count. Oh, that's embarrassing. 1, 2, 3, 4, 5, 6, 7. The x value at both of those points is -7. And there is no part of my graph that's any smaller than that. The largest value is right there at x equals 1. So again, I have closed circles everywhere. So the domain is bracket -7 to 1, bracket. Range is y values. Okay, so smallest y value occurs at this bottom point down here, right? So I'm going to count down to there, -1, -2. Y down there is -3. And I have a closed circle there, so I'm going to put a bracket. The largest y value occurs at the highest point, up there. So let's count up the y's. 1, 2, 3, 4, 5, 6, 7, 8. right? Y equals 8 at that point. So my range is -3 to 8. Okay? So function, yes or no? Let me go ahead and draw in a vertical line right there in black. And 1 intersection point, 2 intersection points. Let me draw another vertical line just for good measure. 1 intersection point, and there's another. No, this is not a function. It fails the vertical line test. Hits the line twice. Okay? That's very taboo. Very taboo. You cannot hit that line twice. Okay? Big deal for mathematicians. We're very picky about that type of stuff. Okay? All right. Let's look at one more example. Okay? Example 6. So here I have this U-shaped curve, and you guys might remember this from the end of Unit 5, but we actually graphed these a little bit. I know it seems like a long time ago, but we actually did, okay? So, let's talk domains, okay? Now, what's the smallest x value here, okay? Now, if I follow along the graph here for a little bit, right, it's pretty clear that, this is going down, okay? It's going down, and the arrows tell me that it's going down to negative infinity, okay? But I'm talking about domain, so I don't really care that it's going down. I need to ask myself, is it going out to the left and to the right? Okay? And so, you'll notice, right, while it's going down, the graph is slowly branching out to the left. Little by little, every time, right? And these arrows tell me that it's going to go down and to the left forever. Same thing on the right side. It goes a little bit down and a little bit further out to the right every single time. Okay? So, since it's going from the left, since it's going further left every single time, right? And then the arrow indicates that this is never going to stop. Okay? So this includes every single negative number. So negative infinity is the smallest value of the domain. And the other direction, what's the largest value? Well, it's going to keep branching out to the right. And that's never going to stop because I have this arrow down here. So, the domain here is negative infinity to infinity. And now, hopefully you guys remember this, right? Infinity always got parentheses. Okay? And now, another way to say this with words is all real numbers. Now, granted, for what we're going to do, that's not going to be a good enough answer, right? Interval notation is what we're looking for. Okay? So, let's talk about range now. What's my smallest y value? Okay? So, here's my y-axis, right? As I go further and further down, again, I have these arrows, right? Arrows indicate this is never going to stop. They're always going to keep going down. So the smallest value is negative infinity. And again, infinity always gets a parentheses. Okay. So, range, what's the largest y value? Well, count them up, right? The highest y value is at that point right there, which is 2. And since that's included in my graph, it gets a bracket. Okay. So that's the domain and range. Okay, a little bit trickier than the previous ones, right? Arrows make all the difference here. If you've got arrows, you're money. Okay. Now, last thing, is this a function? Yes or no? Well, if I draw a vertical line, right, I'm only going to hit it once every single time. Okay. And I can draw as many of these as I want. It's only going to happen once. Yes, this is a function, and that's because it passes the vertical line test. Okay. Sorry, just checking something here. Okay. All right, so we've looked at domain and range with tables / ordered pairs. We've looked at graphs, okay? And now the last thing to do is look at equations. Okay? So, this first one, find the domain and range of x minus 3 squared plus 4. Okay? There's a couple of things that we can figure out from here, okay? And we'll touch on this more as we go along this chapter and next chapter, all right? But here's what's happening here, okay? Any graph with a exponent of 2 right there, right? That's the biggest exponent, right? That's the degree. Remember this from chapter 4, right? Oh, wow, not 4, you idiot. The degree is 2. That's the biggest exponent in this problem, okay? So, whenever you have that, right, this is our U-shaped graphs. And that looks like a V. Nicely done, Mantra. Okay? Remember, our U-shaped graphs can either open up or they can open down. All right? So, the first thing we want to look for is, where is the vertex? Okay? The vertex you're going to find by taking the opposite of that value in the parentheses with the x. So if that's x minus 3, the x-coordinate of the vertex is positive 3. The y-coordinate of the vertex comes from whatever value you have outside the parentheses. That's a positive 4, so it's a positive 4. So, vertex here is 3, 4, okay? Now, if we remember back from chapter 5, when we graphed these a little bit, right, the vertex is where the branches would come from, okay? And so these are going to branch up and out, okay? Now, this is not a perfect graph, okay? If we wanted to, using the skills we got from yesterday, we could plug this in the calculator, fill out a table, and plot some points and get a pretty nice graph. All right, but we're not going to do that. Okay? But in general, right, all quadratics either have this up U shape or the upside down U shape. Okay? So, now let's talk domain. Domain here, okay, again, I have arrows. Arrows are huge in this section, okay? And again, as I go out to the right, I keep going a little bit further out every time. As I go to the left, I keep going a little bit further out every time. And the arrows tell me that's going to keep happening forever and ever. So the domain here, again, is negative infinity to infinity. The smallest value, right, there is none. It's negative infinity. The largest value, I'm going to keep going out to the right, so that's going to be positive infinity. Let's talk range for this graph. Okay, what's the smallest y value I have here? right? Again, here's my y-axis going up and down. The smallest y value I have on this graph is from my vertex right there, right? It's y equals 4. There's no part of this graph that hits any y value less than 4. So the smallest is 4, and the largest, well, again, arrows are your best friend. Well, math frac is your best friend. This is your second best friend. Right? Arrows mean this is going to go up forever and ever. So this is going from 4 to infinity. Okay? That's your range. All right. Let's do a little bit of summarizing here. Okay? Now we have a quadratic equation, right? And this is kind of like general form here, okay? A parentheses x minus h squared plus k, okay? First of all, you have the vertex, okay? The vertex is going to be h comma k, okay? So in the example above, h was 3 and k was 4. All right? That's our general example. This is going to work every time. The domain every time for any quadratic is always all real numbers. Negative infinity to infinity. And the range, the smallest value of the range here is going to be from k to infinity. Okay? Now there's one little caveat to that, right? That has to do with this a value. If a is greater than 0, right, if it's positive, your graph is going to open up, right? And k down there is going to be the smallest value. Now, you could have a situation where a is less than 0. In this case, this parabola, this quadratic equation is going to open down, and now all of a sudden, k has become your largest y value. Okay? Okay? We'll talk about this a little more after we get back. All right? All right, let's keep moving along for now, though. Okay, let's look at another one. Find the domain range of the absolute value of 5. Okay? The nice thing with absolute value is that it is extremely similar to the quadratic equations. Okay? The vertex here, you find it with the same method. Okay? So, inside the absolute value here, right, you're not adding or subtracting anything. So the x value is 0. Okay? Compare that to what we did on this last one. I was subtracting 3, so I took the opposite value there, and the vertex became 3. I would do the same thing for absolute value, but I'm not adding or subtracting anything. Okay? So the x value here is just 0. And the number on the outside, the minus 5, becomes the y value. So 0, negative 5. Okay? There's that point down there. I already went ahead and graphed that. Let's do domain. Domain here is going to be all real numbers, just like with the quadratic, rx squared. Range is going to be very similar, right? Your k value here is the smallest value of the range. It's negative 5 to infinity. So here's what the graph of this looks like now. Okay? Now assume I could draw right? But the absolute value graph is a perfect V shape. Two straight lines jutting out, okay? So something like that. And now we generalize, okay? Here's a general absolute value equation. A times the absolute value of x minus h plus k. Domain, all real numbers. Negative infinity to infinity, right? Look back at our graph, right? We're going out to the left and to the right a little bit further every time. Arrows tell me I'm not going to stop. Okay? Vertex of this graph was, again, h comma k. In this case, it was 0, -5, right? The one above. And the range is going to go from k to infinity. Now, again, this is dependent on a being greater than 0, right? This a value. If a is greater than 0, you're going to have an absolute value equation that opens up. A is less than 0, your absolute value equation is going to open down, right? Now, all of a sudden, k's become your largest y value. Okay? All right. Last one we're going to look at is the square root. Okay? This is the square root of x plus 1 minus 2. Okay? Notice the minus 2 is not inside the square root. Very common error. Okay? Same thing. Let's start with the vertex. Okay? And it's the same thing. Whatever's inside here, right? So whether it's inside the x squared, inside the absolute value, or here inside the square root, you're going to take the opposite of that number. So that becomes a -1. And that becomes the x-coordinate of your vertex. And the number outside of that, -2, becomes the y value. So the point here is -1, -2. Okay? And now here's what the graph of this looks like. Okay? So we're doing a really rough estimate here. Okay? But we can notice a couple things. It's going to go out to the right, and it's going to be going up a little bit every time. Okay? Let's talk domain. Here's my x-axis. What's the smallest value? Well, it's at my vertex right there, right? -1. And now this is going to the right, and I have an arrow here that shows me that forever and ever. So it's going to go out to infinity. Okay, I'll erase that little line thing there. Now let's talk range. Okay, here's my y-axis, right? What's the smallest y value I have? It's right down there at -2. There's no value smaller than that. So now I'm going from -2, and like I said, right, I'm going up a little bit every single time, just a little bit further up. And the arrow tells me that's never going to stop. So that's going to happen forever and ever and ever, out to infinity. Okay? So let's summarize. Vertex has been the same every time. You take the opposite of h, comma k. Opposite of the number inside there, so negative h becomes h, comma k. Domain here, my smallest x value is going to be h. And the largest x value is going to be infinity. Range, smallest y value, right? In this case it was negative 2. That was the y coordinate of the vertex. It's going to go k to infinity. And again, this pesky a plays a big role in that. If a is greater than 0, this graph is going to pop upwards. If a is less than 0, this guy's going down. And now all of a sudden, k has become your largest y value. Okay? So it's very dependent. All right? Okay, so I realize that there was a lot of material to cover today. All right? Do your best on the homework. Okay? I think we should be good with the first page, the second, and the third. Okay? If you don't feel comfortable with the last page, which is this material with these graphs and these equations, numbers 15 through 28, okay? If you don't feel 100% comfortable with that part, that's okay to skip it, right? I won't be super mean when checking homework on Monday, all right? So, give it your best shot, all right? If you have any questions, right, feel free to ask the sub or Mr. G or whoever's there, all right? And I will see you guys very, very soon. Bye.